Org. Today we're going to be talking about atoms, ions, and isotopes. We got a little preview of our definitions here, and we'll go further into them as we move on. All right, let's get down to the next one. Let's keep it rolling. All right, just talking about the atom here. This atom has 10 protons. We use protons to identify our atom. We look up at the periodic table and see that neon has an atomic number of 10. So therefore, this atom here is neon. In a neutral atom, okay, the number of protons and the number of electrons are going to be equal. Also, in a neutral atom, you take the atomic mass, subtract the atomic number, and that's how you find your number of neutrons. If we look down here at the octet, an octet means you have 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. These are our outer electrons. If it has an octet, if it has 8 valence electrons, then it is stable. These are known as the noble gases or the inert gases, which means unreactive. Moving up. Might stand off to the side a little bit on this one. Get it all in. All right, now we're talking about isotopes. Isotopes are atoms with the same element with different masses. They have different masses because they have different numbers of neutrons. Here we're going to look at isotopes of carbon. And if you notice, all carbon atoms always have 6 protons, no matter what. No matter if it's an isotope or an ion. In isotopes, we're not really talking about the electrons. So the electron structure for all of these carbons is the same. But where we start to differentiate is at the neutron level. This atom has 6 neutrons. So this carbon has a mass of 12. 6 protons plus 6 neutrons equals 12. We can also just call this carbon because this is our most common form found on the periodic table. Excuse me. Here we have 8 neutrons. So this has a mass of 6 protons plus 8 neutrons. This has a mass of 14. So we call this carbon as the first name, 14 is the last name. It's still carbon, but it's a different version. And this carbon here has 10 neutrons. So it has a mass of 16. So this is carbon 16. All 3 of these are carbon. They are just known as isotopes of carbon, slightly different. All right, finally down here, we're talking about ions. Ions are atoms that have changed. They have gained or lost electrons. The reason they've done this is to become stable, because they want to have that octet. And as you see here, none of these atoms have an octet. This here has 12 protons, so we know it's magnesium. If we look at the periodic table, we see magnesium is in group 2, which means that it has 2 valence electrons. All right. It wants to have an octet, so it has 2 options. It can fill the orbital it's in now by adding 6 more electrons, or it can lose 2. The easiest thing for this magnesium to do is to lose these 2 electrons, and by losing these 2 electrons, it now has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. It is now stable, it is now happy, it is now an ion. And because I gave away 2 negatives, I got rid of 2 negative things from my life. So if you get rid of negative things from your life becomes more positive. How much more positive did this get? 2 more positive. Look over here at a nonmetal. This is phosphorus. Phosphorus is in group 15 on the periodic table. So it has 1, 2, 3, 4, 5 valence electrons. Phosphorus, in order to get its octet, has the 2 options as well. We can gain 3, 1, 2, 3, or we can lose 5. In this case, it is easier for phosphorus to gain 3. 1, 2, 3. Now it has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Its octet is stable. It is now an ion. And now, if you get more negative things in your life, like phosphorus did here, it got 3 more negative things that happened to it. So now it has a charge of -3. I hope you enjoyed our review of atoms, ions, and isotopes. We'll catch you with the next episode. All right, you hit stop. Gracias.
Muy bien.
I appreciate it. Have fun doing your quiz. Quick planet. Take so much of your time.